Hello again, and welcome to Section 5, Ethereum Project Development. In this section, we'll be looking at different steps, decisions, and approaches that we may face when launching a decentralized Ethereum application into a production environment. We'll start out by getting our production environment ready and installing our testing tool suite. Then, we'll use the tools we installed to perform a walkthrough of testing a smart contract end-to-end. After that, we'll learn how to upload and verify our code onto Etherscan to make the code of our smart contract more transparent. Finally, we'll learn about using the ENS domain name service to replace Ethereum hashes with human-readable names. This works much in the same fashion of how the DNS protocol replaces IP addresses with human-readable names on the internet. In this video, we're going to start assembling a production environment for our tic-tac-toe dApp. Let's begin by taking a look at our project architecture and our folder layout. In the root folder of our project, we have the source directory, of course, and in there we have all of our React.js code for the front end of our dApp. Then side by side with the source folder, we also have the contracts folder that holds the contract code and the ABI. Since Ethereum dApps handle the processing of financial transactions, it's important to use highly secured smart contracts that have been tested end-to-end. Right now, in 2019, the Truffled Framework is widely known as the best framework for unit testing smart contracts programmed in Solidity. So that's what we're going to be installing today. You can see their website is truffleframework.com. Now, luckily for us, Truffle Framework is also released as an NPM package. So it's pretty simple to get up and running quickly, and the instructions on NPM are pretty basic and pretty helpful. You're also really going to want to hang on to this URL. This is truffleframework.com/docs. You go here, you select Truffle, and then you get your table of contents. You might find you actually do need to come to this page, and it will guide you in case you have any difficulties along the way. The reason I inform you of this is because I know full well that Truffle is frequently updating their NPM package. So what you might see demonstrated in this video might have changed by the time the NPM packages got to you. So just be aware of that. Let's go ahead and install Truffle. We're going to do this, of course, as a global NPM module, like so. Personally, I don't need sudo for this command, but if you find that it fails because of privileges, you can try running it again as sudo npm install -g truffle. So there we go, it didn't take that long. So now that Truffle is installed, we need to choose a place where we're going to install our test suite. And that's where we're going to drop in the files that are our smart contracts from our dApp and run our unit tests on them. So let's make a directory called tests. Go there. See, we're in an empty directory. In order to install our Truffle test, well, maybe we'll just make sure we have Truffle. We can do which Truffle. There we go, we've got it. Now the command to start a unit testing environment is truffle init. Just give it a moment to process. Oh, we see it's done some work. So here we go, the steps preparing to download the content. It downloads the content that it needs to make the test suite for you. Gets rid of temp files, thank you. And then it sets up the box. Basically, when you see things like unbox successful, setting up the box, you can think of this roughly equivalent to Node package management. When they say box, they mean a package. And unboxing, boxing, setting up a box, this is just the language of Truffle. But basically, when it says unboxing, it is just unpacking all of this stuff. So you see we get contracts directory, comes with one migration Solidity file. Then in the migrations folder, we just get an initial migration. That's basically setting up this test suite. If we look at what's inside the test folder, there's going to be nothing. We haven't put anything there yet. Then, of course, we just have our Truffle config. And you can see if you look at the config, everything's commented out for now. But of course, we need to figure out which test net we're on, that kind of thing. Once we start running Truffle commands, what we'll notice is that we'll also have a fourth folder placed here called build. You can think of the build directory like a distribution folder. It contains compiled output from Truffle, so you don't want to directly edit any of the Solidity files in the build folder. And if your project is version controlled, you'll definitely want to add the build folder path to your git ignore. Now, for the most part, we're just going to be using the default Truffle settings, but there is one thing that we will need to change. If we scroll down to the compilers at the bottom of the file, what we need to do is put the right version of our Pragma Solidity compiler in here. Basically, we need to have the same Solidity Sol C compiler version as the version that we're using in our smart contracts. So you can see I've opened up the tic-tac-toe contract for us here. And all that we need to do is copy our Solidity value for the compiler into here. We can just go ahead and save this file. The next thing that we need to do is from our React app, we need to take our two Solidity files and copy them into the contracts folder in our tests instance of contracts. So there we go. Now our contracts directory in our Truffle tool suite looks like this. We have our libstring file. We have the migrations file, which is a default file that Truffle has included for us. Then we have our main smart contract, tic-tac-toe.sol. So since we already have this default file that Truffle created for us, we can open it up, take a look at what's going on here. As you can see that this particular Solidity file, and with good reason, is specifically engineered and written in a way so that it can work with many versions of the Solidity compiler. Basically, you want a default migrations file to work with most projects. The term migrations itself is Truffle's language for its strategy for managing what's already been compiled, what's been deployed, and of course what still needs to be compiled and be deployed. Suffice to say that it's a default file in every Truffle project and you won't really need to change it. The reason why is because as your project is evolving, you're adding new Solidity files all the time. Instead of changing the contents of migrations.sol, we only have to write a new migration strategy, and the migrations.sol will pick up on this migration strategy. Of course, the way that we're going to do that is by placing files in the migrations folder. So here you can see I'm still in the root directory. I'm going to go into the migrations directory, and I'm going to create a new migration file. The normal convention here for creating migrations in Truffle is that we will number them in order of how we drafted up and created these migrations. So you'll see that our second migration, which we're writing here, we prefix with the number 2. And inside our migration, we're going to have this code. So as we saw with the first migration, we do need require instances that will import our 2 smart contracts. After we've imported them, we can choose how we want to be using them in our project. The first thing we do is we deploy the libstring contract. This will give us access to call the libstring contract directly. The second thing that we do is we link these 2 contracts. The reason why we link these 2 contracts is so we can set up libstring as a dependency of tic-tac-toe. This will enable us to call tic-tac-toe and use functions from libstring using the regular contract inheritance principles. So after we've linked them, we deploy them again. We deploy the tic-tac-toe instance, which has the linked instance as well. In order to bootstrap a private Truffle blockchain, we're going to use the command, just make sure I'm in the right directory. Here we are again at the root of our test folder. So now we can go ahead and launch the command truffle develop. Just give this a moment to finish running. There we go. So we've now started our own private JSON RPC protocol and our blockchain instance. And it came with these accounts. So we have 10 accounts that we can use. And we have their private keys for them as well. You see that we also get a truffle develop prompt. And if we want to run truffle commands from the truffle develop prompt, because we have a truffle prompt, we simply need to write migrate. Just give this a moment to compile our newly added contracts. And you can see that our newly added dependencies were compiled. We get transaction data for each of our dependency deployments. Then we get a final status. You see we have deployed 3 contracts. Of course, we deployed tic-tac-toe, libstring. We also deployed the original migrations file. If I were to type migrate a second time, you can see the status is that everything is up to date. There's nothing more to compile. So Truffle is smart enough to know when it needs to run a migration and when it doesn't. However, it's not smart enough to detect when changes have been made to our original file. So if we were to reuse this migration and add another dependency here, then what you'll notice is you'll actually get the same output from Truffle. Truffle really wants to treat each new migration as its own entity. But if you have a failed migration that you need to fix, and you need to rerun the same migration, the way that you can get this to happen is just pass the reset flag. When you run migrate -- reset, what you're going to be doing is just redoing all migrations. So it's going to even do the first migration, just reset you to a fresh instance. So that can be a helpful flag to add to the command. Something else to note is that we're actually running a Node.js terminal here. Exit our truffle develop prompt, should we so desire, would be the same way that we exit a node terminal with process.exit.